Hey guys, just a quick little video update on the Hail Design Tech torch height controller. And this will just be like a Q&A session about answering the most popular questions I get about my torch height controller. And you'll have to forgive me, I'm kind of in the process of moving. So all of my stuff is getting it's like a hurricane through here. So I had enough time to put together a little video to answer some of these questions. So I think I could do that for you guys without being like MIA for the last like couple weeks. Driver board, Arduino Mega, display screen and fans. Okay, so I'm gonna load the firmware onto the Arduino Mega with just the provided USB A, I think it is, to USB B. I don't remember. But pretty standard cable. Plug this into your computer, and then you should be able to flash the firmware with the instructions next. Let's do that. And also I can point out that it doesn't have to be mounted to the back plate to flash it. You can do it before you even put it in there.
Okay, the first thing we're going to do is go to the Hail Design Torch Height Controller GitHub page. And then on here, we can actually use the new release thing. Click on releases here. And then if you're using a Mega, go with this package. If you're using an Uno, go with this one. And it depends on the board, and I recommend using a Mega if you can. We're going to click on this file here and download it. It should show up as a download, as well as the THC graphic user interface. And this is for loading onto the screen. We'll download that. Oh, already downloaded it before. Okay, so that's kind of the first step. Close this out. Next, we'll fire up the Arduino IDE. You can download this from Arduino.com or .cc, something like that. It's pretty famous. Just Google Arduino. And this is the Arduino IDE. I'm using an older version, 1.8.12. But it works for me. I've got my Arduino Mega plugged in, and it's picked up on COM3 already. But if it doesn't pick up for you, go to Tools, go to Boards, and select Arduino Mega or Arduino Uno, depending on what board you're using for the torch height controller. Then it's going to be either Arduino Mega 2560 or the 1280, and I have not tested any 1280s before. So next we need to load in that file we just downloaded from GitHub. So go to File, Open, and navigate to Downloads. I'm on another screen, hold on. And open the torch height controller. And if you download for the first time, you might get this message box. It's just a thing that helps the IDE figure out what projects are what and keeps files together. So it'll go ahead and create a new folder called this. And that will surround that file we just downloaded with this neat little folder. So it's now in here doing its thing. So we can just open it up. And let's hit the couple things that I want you to check before we go and compile this. Just scroll down until you find these. And these are the libraries that are external code that this needs to use to operate. And each one of these has a specific version that we're using. So for the next gen, it's 1.0.4. and I forgot to update this. This is for Uno, and it's 1.0.5 for the Mega. And that was because for some reason the 4 wouldn't load or compile with the Mega. Then we're going to use these versions here and this version here for the other libraries. So it's listed here and then where to get them if you don't do what I'm going to show you. So to get these libraries, because you won't have them, you go to Tools, Libraries, Tools, Manage Libraries. Then we go and search for them by name. So this will be FastPID. And it should come up like this. This one's by Mike Matera, and it's version 1.3.1. That's the version that I have installed. And if the version, make sure you select that from the version list. If there's a later version, my code is only compatible with that version. So click Install, and you should, once it's installed, this install thing should light up. If it doesn't, then you can close this and refresh it, or just retype in the name. Next, let's do the easy connection. Oh, I gotta spell easy right. Okay, easy connection library, and this just takes out a lot of the boilerplate code and makes the job of talking to the display a little bit easier. And for the Mega, I'm using 1.0.5 as the version. There is a 0.6, but I haven't tested that. So get that installed, and then install the Excel Stepper by Mike McCauley. Probably murdering his last name. And that's version 1.61.0. Get that installed, and I believe that is the latest version here. And you don't have to install this one because this one gets shipped with Arduino. This is one of their libraries. And that's for the Mega. And if you're using the Uno, there's another one called EEPROM MX. EEPROM EX, sorry. And you'll need to download that if you're using the Uno. Next, we take a look at our pinouts. A1, and you can change this to any of the A's. Where I just chose A1. And that'll be where the input from the plasma cutter comes into the board, the Mega, or the Arduino, they're the same. Same for the step and direction out signals that go to your driver board. And you can also pipe these, anywhere you want. So 3 and 4, 3 is step, number of steps, and 4 is the direction, high or low. And that's just about it for setup. There's not much else you should really do in here. I would come down here and default your steps per millimeter if you know that, if it's different than 200. And with a torch height controller, it's roughly steps per millimeter. It doesn't have to be exact because it goes off of arc voltage to get its distance, and it doesn't actually convert it to millimeters. This is only for display. That's the only thing it cares about, whether you're actually moving 1 millimeter in real life, and we'll show on the display. So come down here and fix your steps, set up steps per millimeter. This will be an insane number. For me, which seems to work because there seems to be some sort of disconnect in my motor driver and this MIG's driver board, and it requires these crazy high values, but most of the time these are going to be pretty low. So if you have any issues with your motor speed, then you just need to crank these up. And I was just adding a 0 until I found it, kind of worked the best. And then that's about it. There's nothing else you really need to do. Everything should be already set up in here, unless you really want to get into the nitty gritty and you like that kind of thing, go for it. It's open source. Feel free to play around and modify this as much as you want. Okay, we're just about ready to upload this sketch to the board. One more thing first, though, is I want to clean up my board just to make sure it's going to be a good upload. So what I want to clean up is the memory addresses that this sketch will check and read and write to. So they're initially set, or supposed to be set to 0. And if they are set to 0, we'll do initial settings. So if this is not originally set to 0 for some reason, you could have some odd results when you first load the sketch onto your board. So let's make sure that all of our memory addresses are set to 0 by going to File, going to Examples, hopping way down here to the bottom, going to Examples for Arduino Mega, click on EEPROM, and then this guy here called EEPROM Clear is what we want. It actually opens in a secondary screen, and it's a real simple little thing. It just goes through every single memory address and then writes it to 0 for us. When it's done, there's a little LED on your board that'll turn on. And this whole process takes a couple seconds, probably like 15 to 20 seconds, something like that. So run this. It doesn't hurt anything. And then wait. Once it's done and it says upload complete, wait for the LED to turn on your board. You'll see it happen. Okay, once it turns on, then we can go ahead and close this out. And now we're ready to actually upload this sketch. So we go up to the top. We can do a check. And that'll just make sure everything we did for downloading libraries was okay. And it'll just check the code for problems. And it's done compiling, and there's no problems. If there are problems, go ahead and report those to the Openbuilds build forum, and hopefully some of the members of the community have seen that and are able to help you. I can click on Upload now, and that's what I want to do. And this will actually flash the firmware for the TorchEye controller to the Arduino Mega. So to do that, let's flash it. Uploading done. All right, pretty simple, right? All right, next let's upload the screen firmware to the display board. And to do that, we're going to go to our downloads folder where we had that. Hold on just a second. I'll pull it over. I'm going to grab it from my downloads. Not that one, this one. Bring it over here. And so this installs really simple. There's no libraries. Everything's all compiled for this one. All we need to do is plug in our SD card to our computer or reader or something like that. Okay. It should be at least 2 gigs, but no greater than 32 gigs, and should be formatted in FAT32. Then all you need to do is drop this file onto your SD card. Once you copy this to your micro SD card, then you can close this out, eject the SD card and remove it from your computer, and we'll go ahead and cover the steps for inserting that into the display board.
One messy thing about this design is the SD card reader is inaccessible if the display is in its bolted down state. So we gotta take it apart. 1 second. Okay, so I got it pulled out of the screen, and then I've got my micro SD card. 32 gigs, the maximum it'll take, but it works. And we'll insert the SD card. Just try this with one hand. Okay. Wait for the click. Clicks in. And that's the way you want to click it. Not the opposite direction. So now we're ready to flash. So with the SD card in there, we'll hook it up to power from the Arduino. So for flashing, it technically doesn't need these communication wires plugged in. So we'll leave those out. So it goes into bin. No, not bin. Red goes into 5 volts. And black goes into ground. Like so. And I'm using a little connector kit that has the extender pins on it. We can get those off Amazon pretty cheap. And now we got our board ready for power. I think it's probably upside down, but we'll see. And then we just plug in the Arduino Mega to the computer, and it'll provide power to the display. Okay, so it's reading the SD card, and this read takes a little while. And when it's all done, it'll do a little compile and then upload it, and it'll say firmware or something completed when it's done. So let's just wait for this to get done. I'll fast forward. All right, getting there, 90%. Yours might be faster if you got a smaller SD card. And data check, and then update succeeded. That's what you're looking for. Right there, update succeeded. Okay, now let's unplug it and remove the SD card. If you, be careful, don't unplug it, plug it back in accidentally. You want to commit to the unplug, just pull. Because it'll try to load the firmware again if you cycle the power like that. So, boom. And I like to unplug it like that rather than shutting down the Arduino because there's some capacitors in here that take a little while to die. So I just put it better like that. So, remove the SD card. And our firmware should be loaded now. So to confirm the firmware load, we just plug it back into power. Here. Like so. And it's upside down. But you get it. All right. And then next, let's confirm that it actually has some signals going on here. So let's move it around over here. And you can plug in the signal wires. Now, it should be in TX and RX. Yellow should be in 18 and blue should be in 19. Or yellow should be transmit from the Arduino and receive on the display board, and transmit from the display board should be receive on the Arduino 19. So we'll plug that in. Eventually. Okay. As soon as I get it plugged in, I get my free voltages because I don't have anything plugged into my A1. But you should automatically start to see that updating if everything's working. Okay, so we confirmed everything works. Our data line and our power for the next-gen screen. So let's confirm that our plasma input voltage works. So let's set up a cheater circuit. I'll show you a quick way to do it with a small potentiometer that allows me to adjust my input voltage here between 0 and 5 volts, and that'll allow me to mimic a plasma cutter, and so we can do some testing. So let's get that going. Okay, here's the simple setup. Just uses a potentiometer of any any kind of resistance. Then we've got a wire going from ground over to ground, then allows a path to go through, and we pull from ground. We go into ground on the potentiometer right there. Then the middle leg of the potentiometer, we pull the line off, and then we go back to positive on the outline of the potentiometer. Go to positive over here, and then positive into 3.3 volts. Doesn't matter, you can use 3.3 or 5. 3.3 is easily available, so we'll use that. And let's go ahead and power the system up. Boots up. And nothing, right? Wrong. It's actually going through its motions. It's trying to cut something right now because this pot is way too high. So let me turn that down. Yep. There we go. And then now it shows up. So now I can control the voltage. So my set point I want it to get to, it wants to get to 109 volts. So right now it'll move the torch position to do that. So I just crank my potentiometer up here a little bit. And as soon as I get over the threshold voltage, which I believe is defaulted to 50, it'll go into cut mode. No, it's defaulted to 40. So see that moving? So let's go over 109 if I can. I don't know if I can yeah, I can. So then it's trying to move the torch up. It's like, oh, I'm way too high. Now I'm way too low. Now I'm way too high. It's just trying to chase that voltage to get it to match up exactly. And if it's within a couple volts, then it just barely moves. See that? So that's how the torch height controller works. So we run this back down and off. So there's no voltages going through. And when it's in cut mode, and it's actually moving these numbers right here. If you see numbers here, then you're in cut mode. So if it's in cut mode, you won't get any other input. Everything will be zeros all the way across to your board. So if I go into here, I'm not in cut mode. So let me go into cut mode. So let's go into cut mode by supplying a voltage. There we go. So now it's in cut mode, and the Arduino is completely focused on this cut, and it doesn't update these screen buttons. So if I go over here, they're all zeros. So if I get out of cut mode, we'll back this guy down, and it'll come back and refresh the display. Okay, so that's how it should work, and that's a good way to double check your wiring, make sure everything's good, test everything on this little simple bench setup here. And then from there we can include motor driver and get that going out correctly. So out of pins 3 and 4 over here, step and direction, and then 13 and ground for enable, and then the ground for the input of our mix driver board. So let me, I guess the next logical step is to plug in this driver board, plug in some power, and see if we can get our stepper motor to move. So let me go get that all staged and set up. Okay, I got everything set up again. And I've got clock, enable, clock, direction, and ground. And clock is step in the Arduino sketch. So those need to be wired into the correct ports here. Step is 3, which goes to clock. Direction is 4, and that needs to go to direction. And then enable and ground. Enable needs to go into 13, and ground needs to go into ground right next to it. And then I've got my little bench power adjustment system. So I'm not using my input for my plasma cutter, or I would use that, which would And then I got my regular power for my next-gen screen, and then talk and signal screen. Or then communication wires, blue and yellow there. So not much has changed here, except for I just added my board, and I've got positive on the top one here, and then ground on that second one, and then motor wires out. I do have, let me get this on the way here. These are my settings for the Mix board. I don't think I've ever showed these before, so I'll show them now. 1, 2, and 3 are determining the steps per millimeter, steps per pulse you get from your Arduino. And then 4, 5, 6, and 7, I believe has something to do with 4 is power dampening or something like that. 5, 6, and 7 are voltage settings. So I think I'm running 2 amps or something like that. But go ahead and steal mine. I got everything off. 1, 4, and 7 are on. Try that and then play around with it from there. But the instructions for these settings here are literally on the back of the board. And then wiring a stepper motor, there's plenty of information out there for how to wire a stepper motor. So get that all set up. And where is it running for me? It's running to my torch. Runs into this actuator motor, moves my torch up and down, and I'm good to go. So let's plug it in and turn it on. Let me show you what it does. Okay, power cable, plugged in. Okay, we want this to be 10 volts, about. No higher than 12. Or you're running to frying your board. That's always a fun thing to do at first, and then it is not so much fun after that. So 10 volts, and around 5 amps. Plug this in, hopefully double check our wires, make sure nothing's touching where it shouldn't be. Looks good. And plug this in, boot her up. Make sure this is set over. Boom. My board clicked, so we're good. I set on 3.3, must have bumped it. Oh, hold on. Set that back to around 109. Doesn't have to be perfect. 110, close enough. All right, you can't even see that. All right, so if I turn up my pot, I start to get a voltage. Anything over 40, it starts to get into cut mode. So it'll send up and down signals to my motor driver, which will then go through this Ethernet cable, which powers my motor, and my torch and torch actuator. So let's play around with this, and let's watch the. I'm gonna turn this pot up. Watch the. Okay, going back up and down. If it's higher than the set voltage, it goes down. If it's lower than the set voltage, it goes up. Moves back and forth. And just by setting the potentiometer. And when it's really close, it still moves a little bit, but not much at all. And so that's the idea. So the closest it gets, I mean, if it's around where it should be, then it's gonna go to where it should go. And when it's done with the cut, it'll reset to 0, like that. Goes back to 0 when it's done with the cut. All right, so that's kind of the demo. This is technically demo number 2 for me. My camera died the first time, but hey, there we go. So that's how it should work, and it should be picking up voltages and everything looks good. If you follow the the guide here, as like this video is my guide. Follow that and make sure you're using the right hardware. Hardware is available on Openbuilds except for the Arduino Mega. That I have a special video about just for that. But it's an Arduino Mega 2560. And it's an official Arduino Mega, not a clone. Clones have problems with EEPROMs and power regulation and all sorts of stuff. So stay away from those if you can. I know they're less expensive and they're enticing in their less expensiveness, but you run into other problems with them. So that's it. So up and down signals goes to driver, driver goes out goes out to this line here, about to lose a screw, out here into the motor, and then up and down signals, and there's a feedback loop. The plasma cutter will deliver a different voltage depending on the height, and we're good to go. And that's how she works, man. So let's put her back together through the magic of video editing. There we go. Back together. So it's a nice little box, bunch of little wire routing crimes happening in there at the moment. Plug it in. Boots up. And then it picks up that 109, so that means it's talking to the Arduino in there and getting that set point from memory. If I set it to something else, like that, then switch over here, and switch back, and it sets to whatever I remembered it. And that's why it's using the EEPROM in here. And that's why you need to do that clear thing that I showed you. But yeah, looks like it works. Got motor in, signals in, work out. Busy fans in there. Look at all those aluminum spray chips in there. It was plasma cut in some aluminum, and it was spraying stuff everywhere. But yeah, she works great for me. It took me a little while to do the dial-in of the settings for the speeds and feeds like I was showing you, for the PID settings, but figure that out. Just turn some metal into scrap for a little while until you figure out a good balance for your plasma cutter. Also, it'll slowly count up voltage here because it's slowly storing stuff in the capacitor. And if you unplug it for a little while and then come back, it'll reset. So when I'm done using, I usually unplug it. Actually, I don't leave it running because the fans always run when you have it plugged in. So it's actually tied to my plasma cutter, and when my plasma cutter's on, it's running, and vice versa. I just do that through a power strip. But yeah, pretty cool, right? So that's the Hale Design Tech TorCHAC controller, and she works pretty well for me. And I hope that you find this project useful and can build one of your own. If you follow these steps, you should be able to achieve the results that I just showed you here, because I didn't do anything special. I just did exactly what I just showed you. Okay, let's go into some Q&A about the whole process of the TorCHAC controller and answer some of the most popular questions I get about the TorCHAC controller. Why not, shall we? So the TorCHAC controller is a standalone unit, and most people don't quite wrap their heads around that coming into the project. And that means it does not talk to a control board. Let me move the camera around here a little bit. So first off is the TorCHAC controller. I designed it to meet my needs and my setup. Well, the question that I get most often about the TorCHAC controller is, how do I get it to talk to my main board? And this is just a dummy little main board. It's not my actual one. I actually use a Duet 3 main board for my plasma cutter, which is probably also not common. The TorCHAC controller actually does not talk directly to my main board. And that's where the word standalone comes in. So it has its own motor driver, and it actually puts out a powerful enough signal to run a stepper motor, a NEMA 23 size stepper motor. And you actually tune the amperage on the driver in here as well. And that allows me to bypass this whole board completely. So I don't need to talk to this board at all. Instead of talking to that board, my main board, or your main board on your plasma cutter, I just send the signals directly to this guy, which is a Openbuilds actuator with a breakaway 3D printed torch connection. Repeatable, pretty solid. I love that. This design turned out really great. And it's also mounted to these really cheap, order them off Amazon, off-the-shelf DLSR camera mounts. And so a little dovetail setup allows you to slide it in and connect it. And then this whole setup goes into another one of these camera mount things that I have mounted to my main X-axis gantry plate. Slides right in, turn the red tab, and I'm good to go. And that's how my setup was designed. I bypass my main board connection, talk directly to this torch eye controller with the voltages coming off of my plasma cutter here. 102i plasma cutter has a 50-to-1 arc voltage coming out the back. I pipe that directly in to this board, right into analog input number 1, and then ground with a little smoothing capacitor in there. And that's how it works. There's no software package that needs to be installed anywhere. Just make sure that the torch eye controller has everything it needs, and you're good to go. I had this old actuator and I just used it, but I could probably get away with one that uses half the range this does. The torch doesn't really need to move all that much. In most cuts, it only moves half an inch tops. And so that's how I designed it. So the short answer is no, it doesn't connect to your main board at all. However, there's a caveat. It could, technically. You could pipe in your 50-to-1 arc voltage in whatever connector form you want. And also you could pipe out your step and direction signals that the Arduino creates and find a way to route those step signals and direction signals into your main board somehow. This board actually has the ability to take step and direction signals from a secondary source. So something like that might work. But the reason I'm not doing that is there's so many variations in these boards. So many blends of software, different G codes, all sorts of random stuff that we would have to do development for. So I decided to just, I'll just take care of all of my torch eye controller stuff myself, and you take care of moving X and Y for me. Thank you. And so that was my solution to this whole problem, is just a standalone controller that, doesn't need to talk to your main board. So if you do actually implement, if you do actually get it to talk to your main board, I would love to know how you did that. Please post that information on our community forum through the Openbuilds build on the discussion forum there. I would love to hear how you did that. And so that kind of piggybacks into another popular question that I get for the torch eye controller is, can I just hook it up to the Z axis on my plasma cutter? And the answer is no, without disconnecting the Z on your main board. So it's one or the other. You can have this control the Z axis, or you can have the torch eye controller control the Z axis on your machine. And then there's a limit to how much this thing can put out as well. So it depends on your motor. There's a whole bunch of stuff. But if the planets align, you can kind of get it to work out and things make sense. I would suggest, and now I have not tried this. Man, my hands are dirty. is you may want to look into some of these little boards here by Focus. Triangle Lab. These are called TL smoothers. And what they have is a set of diodes on this board that only allow electricity to go one direction across this board, unless it's like crazy high voltages, like 50,000 volts, something like that. So it produces a little bit of heat, and there's a heat sink that comes along with this board. But if you hook up one of these boards coming off of your torch height controller, hook it through this, and then into your connection to your stepper motor driver, you can only send signals one way to your motor, and signals from your main board won't go all the way around and go back into this guy, which is bad. You don't want that. This would stop it. You'll need two of these boards, however. One for your main board on your Z-axis, and then one for this guy. So the idea is they can send signals to your stepper motor driver, and then hopefully not at the same time, because then it will double your voltages and you could blow up your motor. That is an option, another analog solution to a digital problem, I suppose. But those are the ideas that I had for connecting to my main board, and maybe eventually in the future I will. Right now, I looked into the main board that I'm using, which is a RepRap firmware Duet 3 main board, and it's limited to how I can do external inputs to my board because the way the software is written. So software will need some touching on my setup and even to start to use something like this. Your boards will differ widely, and I have no experience with the boards that you're using, so I can't comment on how to connect them. And then finally, the last question I get about the torch height controller, the last main one, is kind of setup and how to get it working. This is an initial version of the torch height controller. It's much in its infancy. There's a lot of problems with it, I think, but overall it seems to work for me, at least the way I have it set up. I initially used this Arduino, ran everything off of it, and it seemed to work pretty well. But there is a connection lag between inputs on the screen to inputs on the Arduino. Sometimes you got to hit a button 3 or 4 times on the screen before the Arduino finally realizes you want to do something. So there's the next-gen screen interface is not perfect. Other than that, it does do the torch height calculations and move the torch beautifully. I love that part. So the Arduino does its job there. And the screen itself is not technically needed to actually use the torch controller at all. I only use it to set initial voltages, which I could literally just plug my computer in and hard code that. So I get a lot of questions about how to set it up, how to get it working, and as long as you follow the hardware requirements, which I have listed on the Openbuilds build for this, which is a legit Arduino, the right version of the next-gen screen, the right motor driver, then it should be plug and play for the most part. You try to get the same actuator. That would be nice if you can. You can order that from Openbuilds. It's like $100. It's not bad. It should work. But I'm continually looking into ways to iterate and update the software to make it better. So please forgive me if some of the stuff is not completely up to date and you have to do some manual changes or have to work out bugs on your own for the software of the machine. But it does seem to work for me in my setup. But I'll be posting updates in the future and more updates as I can. But in the middle of moving, work is hectic, so finding time to actually work on this project is rough. But I'm working through it, and hopefully have more updates in the future about the standalone torch height controller. That seems to work pretty well for me. All right, thanks guys. Have a great rest of your day. Peace.